So let's look at example 1. Example 1, Kim's back and her donuts. So Kim's donut tasting party was so successful that it propelled her YouTube hits to such a level that she was invited to compete in a bake-off competition on the Food Network. Kim won first prize and was awarded the golden donut. She was so excited when she won that she dropped it and it rolled about 100 meters before she could catch it. If the diameter of the golden donut trophy is 0.1 meters, answer the following. So it says, through what total angle did the golden donut rotate in radians? So if you have a round object and it's rolling, right, the linear distance it traveled actually correlates to the total arc length that it made. So arc length can actually be bigger than the circumference of a circle if an object rotates more than one revolution. So what we were given in the problem was that the diameter of the donut was 0.1 meters. That means the radius of the donut is 0.1 divided by 2, or 0.05 meters, because all the formulas we have involving circles are in terms of their radius, so we need to make that adjustment. We were told that the donut rolled 100 meters, so that would actually represent arc length. So since I'm looking for the angle, we know that S equals R theta, so theta is S over R. So if I plug in 100 meters divided by my radius of 0.05 meters, you can see here that the meters cancel out. So you feel it looks like you have no units left, but remember I said radians are unitless, and that's why this by default will come out in radians. So when we multiply this out, or divide this out, excuse me, we get 2,000 radians. So this is the total angle rotation that the donut had. It says, through what total angle did the golden donut rotate in degrees? Well, if we have the radian measure of theta, we can convert this into degrees by multiplying by 180 degrees over pi radians. So this works out to be 360,000 degrees over pi. So this still is in degrees, okay? So just because there's a pi in the number, right, when we did the conversion, we went from radians to pi. So that will happen if you have an exact integer number of radians. Pi will come up in the degree measure. If your radian measure has a pi in it, the pi generally cancels and you just get a number in terms of radian, or in terms of degrees. This is the exact answer. If I approximated it, if I was allowed to round, but I'm not in this question, but just to give you an approximation of how many degrees this is 1.5 times 10 to the 5th degrees. So it was a lot of degree measures, but you can see in radians it was a nice, clean, neat number. It says, how many revolutions did the golden donut rotate? So how many times did it spin all the way around throughout all this? And this time it told us to round our answer to 1 decimal place. So I can pick either one of these angle measures because I can go from angles into revolutions pretty quickly, but I think it makes more sense to start with the 2,000 radians. It's a cleaner number than this guy. So if we start out with 2,000 radians, well, 1 complete revolution in terms of radians is 2 pi. It takes 2 pi, right, radians to go all the way around the circle. If I had used this guy, right, I would have said 1 revolution is 360 degrees because that's 1 revolution. So now, once again, because radians is unitless, I get 2,000 over 2 pi revolutions, which simplifies into 1,000 over pi revolutions. But I was told in this question to round it to 1 decimal place. So if I take my calculator and I divide 1,000 divided by pi, I get 318.30, so that's 0.3 revolutions. So to roll 100 meters, the donut spun around 318 times and then a 0.3 of another revolution. Problem 2 says a circular sector with central angle 150 degrees has an area of 20 square units. Determine the radius of the circle. So the first thing that I see is I was given an angle of 150 degrees. And I know that if I'm going to do any calculations with my angles, it really needs to be in radians. So I need to convert this to radians. So pi goes on top, degrees goes on the bottom because I want degrees to cancel. 150 over 180 reduces to 5 pi over 6. So this is my angle in radians. The area of my sector was 20. So since I have theta in A and I'm looking for the radius, I want to use the area formula that has r and theta in it. So I need to solve this for r. So I'm going to multiply both sides by 2. And then that's going to give me r squared theta. Then I'm going to divide both sides by theta. And then I'll take the square root of both sides to get r. Now I'm ready to plug in my values. So area is 20. So I'm going to get 2 times 20 is 40, and that's divided by my angle of 5 pi over 6, and all of this is under a square root. When you divide by a fraction, it's the same thing as multiplying by the reciprocal. So 40 times 6 is 240 over 5 pi, and it's perfectly acceptable to leave this like this, but 240 is divisible by 5. So I'm going to simplify it one more step. So this is the most reduced answer we could get. So for most of you, you would be allowed to stop anywhere in these 3 steps. It just really is a preference of how far you want to go.